Hi everybody. Today I am going to discuss about Pascal's triangle. One of the most interesting number pattern is Pascal's triangle. It is a triangular arrangement of numbers that gives the coefficients in the expansion of any binomial expression such as this one. A binomial expression is one which contains two terms connected by plus. We can see it here. It is connected by plus or minus sign. Say if I take x plus y, another term to the power 1, to the power 2, to the power 3 are the example of binomial expressions. Expanding this x plus y to the power n for integer value of n from 0 to 3, we get this expression. And this expression, it is frequently necessary, these type of expressions. When the power n is small, say like this, 2, 1, 3, power is small. I mean power n is small. So in that case, it is easy to get the expression. If n is large, I mean this value, if n is large, this approach becomes tedious. That is why an alternative and very simple approach is to use Pascal's triangle. Now question is, what is the rule for this Pascal's triangle? Rules that Pascal triangle has is that we start with 1 at the top. I mean these positions. So let's take 1 here. Then ones at both sides of the triangle, and this 1 on both sides of the triangle, it will be continued along this line and along this line. I mean this number 1 and 1. Now for this area there will be terms, we call it coefficient. So a coefficient of a term, say here coefficient 2, here 1, here 1. So all these numbers coefficient, we'll get it in this area. So a coefficient of a term we can or may be obtained by adding two adjacent coefficients. Say here adjacent coefficient 1 and 1. Immediately these two coefficients immediately above this. So what we will do? We will find this by adding the two adjacent coefficients immediately above in the previous row. I mean here we are finding, so previous row, these two adjacent coefficients to be added. That's the rule, main rule here. So we can follow this for all this coefficient value. So let's start. Now as I said, along this line there will be 1. So here and here I have to put 1. Now again to get this number I have to add these two adjacent coefficients. How to? 1 plus 2 equal to 3. and other position also 2 and 1, it will be 3. And again same way at both ends I have to put 1 and 1. So we are done. Now for the bottom line, I mean this one, 1 3. So here surely it will be 4. 4. Here 4, here 4. So what about this one? Two adjacent coefficients to be added to get these coefficients. And both ends it will be 1 and 1. Now come here, 1 and 4, 1 and 4. So surely it will be 5 and 5. It will be 5. So you got it, 5 and 5. What about these two? Surely same procedure, 4 plus 6, it will be 10. And then next one will be also 10. And at both ends, it will be 1 and 1. Now 1 and 5 will be 6, 1 and 5 will be 6. We get 6 and 6. And here in 3 positions, we will do same procedure. 10 plus 5, 15. And other position also will be 15. In the middle, 10 plus 10, 20. And at both ends, it will be 1 and 1. So we are done with the triangle. So we got all the coefficients. Now let's put here, we will find 7 lines. These are the lines. Row 0, it means this one. This. Again row 1, it will be second one. And row 2, I mean row 3, no, row 2, it will be this one. Then row 3, it will be this one. And you compare this coefficient 1 3 3 1. It is row 3. It means power is 3. And look at the coefficient 1 3 3 1. So 1 3 3 1. Perfect. So let's move in the next slide to understand more about the terms. I mean how to check the terms, is it correct or not. Now we are here. So what we can do, say already we have seen in previous slides, this was row 0 and equation was this and it was equal to 1. So I am putting it slight far so that all the equation once I set, it will be looking like the triangle as this shape. So let's do that. Second equation, say I am putting this. Third equations. See, pattern is looks like triangle. Good. So we are done with. So here we have lot of things to understand. Here it looks exactly same as this triangle. If you look this here and if you compare this, you will find, say here number, this is 4. You see here 1 4 6 4 1. Look at 1 4 6 4 1. Exactly same as it is. For other two also exactly, coefficients are exactly the same as these equations. Now we understand that Pascal's triangle, it gives the coefficients in the expansions. And from these results, there are some important information emerges. What is that? X decreases in power moving from left to right. Look at, moving from left to right. It says X decreases in power. See here, X here 4, here 3, here 2, here 1. Here also see 6, 5, 4, 3, 2, 1. So it is correct. X decreases in power from left to right. Again, Y increases in power from left to right. For an example, if I take this one, Y here 1, then 2, then 3, then 4. It means Y increases in power from left to right. If you check this one also, it will be same. Here you see 1, 2, 3, 4, 5, 6. So it is increasing. So what you can say? Simply, we can say that the terms in these expansions are composed of decreasing power of x and increasing power of y. Very important points. Another important thing, the coefficient of each term of the expansions are symmetrical about the middle coefficient when n is even. Here you look at n is even. So it is symmetrical from here. If I take this middle, so here one term, here one term. Here you see this is 4. 4 means I have to take the middle one. So right hand side there is 2 terms, left hand side there is 2 terms. So it says coefficient of each term of the expansion are symmetrical about the middle coefficient. Very perfect. But if it is odd, it is symmetrical about the 2 middle coefficients. Suppose I am taking these 5. It is odd. So middle I have to take 2 coefficients. I mean these 2 if I take. So right hand side there are 2 terms. Left hand side there are 2 terms. Very clear. And so we understood it very clearly. Now here I have written the term in the expansions are composed of decreasing power of x and increasing power of y. Another important thing also, always we have to look at, say I am taking this as an example. Here if we look at the expansion of this, what we found? The row in the triangle beginning 1, 4. Look at here. 1, 4, 6, 4, 1. So it starts from 1, 4, 6 like this. But starting this value, we simply insert the appropriate number of x and y. How? Starting with the highest power of x. Look at, this is the highest power of x, namely x4. Again, this is starting and ending will be, this is also important, ending will be with the highest power of y, namely y4. And in between all the terms, it will be combination of x and y. And just look at the points. This is 3, this is 1. See, it is total 4. Just for checking only. Here 2, here 2. So 2 to 4. Here 1, here 3. 1 and 3, 4. Make sure first one and last one, and in the middle all terms will be combination of x and y. And check the power also should be same as this number only. This should be the number same as this one. I think that's all for this Pascal's triangle.